Hey everyone in class 11, exams are coming up, right? And I know relations and functions can feel, well, like a real beast. But what if I told you we could nail the most important stuff in just 5 minutes? Seriously, let's do this.
Yeah, this topic can get super abstract, I get it. But honestly, the main ideas are actually pretty simple when you break them down. Trust me. We're going to cut through the noise and just focus on the key rules and definitions. You know, the stuff that's actually going to get you points on your exam. All right, so first things first. Before we can even touch functions, we got to start with the basics. And that basic idea is something called a relation. It's the foundation for, well, everything else.
Okay, so what is a relation? Super simple. It's just a rule that connects things from one group, let's call it set A, to another group, set B. Think of it like this. If you listed every single possible connection between set A and set B, that's called the Cartesian product. A relation is just a smaller, specific collection of those connections that follow some kind of rule.
Okay, now for the star of the show, functions. The trick here is not to think of a function as something totally new. Nah, it's just a special kind of relation. A relation with one very, very important rule it has to obey.
And here it is, the golden rule. Seriously, if you get this one sentence, you've pretty much cracked functions. It boils down to two things, and they're both non-negotiable. 1. Every single thing in the first set has to be paired up. No one gets left behind. And 2. Each of those things can only have one and only one partner in the second set. That's it. No cheating.
Let's see this in action. Look at the diagrams on the left. They all look a bit different, but they're all legit functions. Why? Because every single input from the first set has exactly one arrow coming out of it. It points to just one output. Now, look at the one on the right. See that? The top input is trying to be in two places at once. It's pointing to two different outputs. That's a big no-no. It breaks our golden rule. So it's still a relation for sure, but it is not a function.
So here's the best way to remember it. An input in a function cannot be indecisive. It has to pick one output and commit. That's it. One input, one output. That is the unbreakable law of functions.
Cool, so now we know what a function is, let's get the lingo down for its different parts. You know, inputs, outputs, they all have official names. This picture basically tells you everything. The whole starting set, all your inputs, that's the domain. Easy. Now, the whole target set, where all the outputs could possibly be, that's the code domain. But, and this is key, the outputs that are actually hit by an arrow, that's the range. See how in this picture, the range is just a part of the bigger code domain? That happens all the time.
So to really drill it in, domain is what you put in. Range is what you actually get out. The codomain is just the list of all possibilities, but the range is what really happens.
Okay, let's take it one step further. We can actually categorize functions into different types depending on how the inputs and outputs behave, and you definitely need to know these for your exams.
All right, check this out. We've got one-to-one versus many-to-one. In a one-to-one function, every input gets its own personal, unique output. No sharing allowed. But look at a many-to-one function. See how multiple inputs can all point to the very same output they're sharing. And that's totally okay for a function. It just means it's a many-to-one type.
Now let's switch our focus to the outputs. This is how we tell if a function is onto or into. In an onto function, every single possible output in the codomain gets used. There are no leftovers. The range and the codomain are exactly the same. But in an into function, see how some of the possible outputs are left out? They don't get an arrow pointing to them? The range is smaller than the codomain?
Okay, exam tip time. You gotta know the fancy names for these. One-to-one, that's called injective. Onto, that's surjective. And what if you get a function that's both, you know, one-to-one and onto? That's called bijective. It's like a perfect pairing. Everyone has a unique partner, and no one is left out. All right, enough with the theory. Let's get our hands dirty with a real problem, just like you'd see on an exam. It's time to put these rules to the test. Okay, here we go. We've got a relation, R, defined by these pairs. The big question is it a function? Take a second and look at it. Remember that golden rule we talked about?
Let's break it down. First, what are our inputs? Looking at the first number in each pair, we've got 2, 3, and 4. Okay, now let's check them. The input 3 points to 3. Cool. The input 4 points to 4. Also cool. But wait, look at the input 2. It points to 2, but it also points to 4. Uh-oh, there's our indecisive input. It's breaking the rule. So, what's the verdict? It's a relation, but no way is it a function.
Okay, let's do a super fast recap. These are the key takeaways. 1. A function is a special relation where every input has exactly one output. That's the big one. 2. Domain is your inputs, range is your actual outputs. 3. One-to-one means unique outputs, no sharing. 4. Onto means all possible outputs get used, no leftovers. Got all that?
All right, I'll leave you with a little brain teaser. Think about this, the relationship between every student in your class and their own unique student ID number. Is that a function? Why? And what happens if you try to map it the other way around, from the ID number back to the student? Chewing on real-world examples like that is honestly the best way to make this stuff click. You've got this. Good luck with your studies.